Hello Year 10, Mrs Connor here again, you lucky lot. If you could rule off where you got to last lesson, please write today's title and the date, and then just have a go at the do now tasks. One is directly related to last lesson, so surface area of the pyramid, and then surface area of this prism. Please pause the video as you do this. Brilliant, well done. So if all is correct, you should have 64 centimetres squared and 320 centimetres squared. Excellent. Right, your success criteria today. So bronze, to be able to calculate the volume of a cone. Silver, to be able to calculate the surface area of a cone. And gold, to apply knowledge to more complex problem-solving questions. First things first, I hope you know what a cone is. But if you don't, it looks like a good old-fashioned party hat. There you go. So it's, you can treat a cone exactly as a pyramid, but this time with a circular base. So the basic formula, the worded formula, is exactly the same. We're doing a third times our base area that we have to find here, times by our perpendicular height. So you just quickly write that down, and then here is the actual formula that we will use. Don't panic, lots of this will be familiar to you. Please pause the video as you record the formulas down, perhaps sketch a cone as well, just to jog your memory when you look back at it in future. Right, brilliant. As I said, sometimes formulas like this can be a bit overwhelming, but actually all of this you have seen before. If we think back to cylinders, again in chapter 14, this is actually the formula to find the volume of a cylinder. Because remember, for a cylinder, you find the base area of a circle, so the area of a circle is pi r squared, and then you times by the height. The only thing that's changed is we're now doing this times by a third, which we know is equivalent to dividing by 3. And the reason we're doing that is because if we just do this, we get our answer as if this cone is a cylinder. Well, a cone isn't a cylinder, it's a proportion of one, it's a third of one. Okay, so that's why we're doing our times by a third. If you think it will help you, you could maybe circle this and put a formula for a cylinder, that might help, or just circle this little bit and put a formula for a circle. Pause the video if you want to whilst you do this, and if you don't need to, you can just carry on with the video. Right, brilliant. First things first then, so we're going to find the volume of this cone, and we're going to find it in terms of pi, which again, we've heard of that terminology before, and then find the actual volume. Now we should know that when we're trying to find things in terms of pi, it actually means we don't need to do the pi part of the calculation, and that can crop up fairly often non-calculator. Sometimes calculator questions, but it can crop up non-calculator. So you can just ignore that part of the formula if you wish. We know that actually with our scientific calculators, if we put the whole thing in with the relevant numbers, you actually get your answer in terms of pi first, and then you press the SD button. So you could try it with your calculator, with pi, and also without it. So here, we know we're actually doing a third times the radius squared times the height, because it's in terms of pi. We'll deal with that later. We know that the radius is half the distance across the circle, so it's 6, and we know the height is 8, because again, the height is always at a right angle from the highest point of a shape to the base, and that tends there just to confuse you. So that's what we're doing, okay? We should know that 6 squared is 36, and again, you might not show all of these stages of your working out, but you can do if you wish. And again, here it's quite interesting. So you could do 36 times 8, and then times it by a third, so divide by 3, or you could actually find a third of 36, which is 12, and then times by 8. Now what I would like you to do, to get 96 pi, is actually do the formula as if it's here for me, and then get your 96 and put pi, but then also put the whole thing into your calculator. So put the times by pi part as well, and you'll notice that actually when you get your answer, the first thing you get on your calculator screen is 96 pi, and then in order to find the actual answer, the full answer, press your SD button and you'd get the answer to question 2. But we'll just quickly talk you through that anyway. So there we're using the whole formula, we're substituting the same values, but we don't want to answer in terms of pi. That's what we'd be given first, so we press the SD button, and that's what we get to 1 decimal place. If you could just pause the video and copy down this example in your exercise book, that would be brilliant. Right, very good, lovely. We're going to have a go at another question now. We're going to go straight in at this one. What I'd actually like you to do is we're going to ignore this in terms of pi bit to begin with, and what I would actually like you to do is just to go with the full formula and put all of the information in. So 1/3 times pi, and it's 4 squared because look, what you're given here is the diameter. We want the radius, which is half of that distance, so it's 4, and then the height is 9. Again, the 10 is irrelevant. Now, when you put this into your calculator and you press equals, the first thing you will get is this. So brilliant, we've got our answer in terms of pi, but what if we want the actual full integer answer? Well, let's press our SD button, and we get 150.8 centimetres cubed to 1 decimal place. Please pause the video and copy this down. Excellent. If you can now have a go at finding the volume of these 4 standard examples here, these 4 cones because they look the same, and then round it to 1 decimal place, and then have a go at finding the volume of these 2 non-standard examples. They're non-standard because they're at different positions, sometimes that confuses students, but also because this time you're rounding your answer to 3 significant figures, something we have looked at previously as well. Please pause the video as you do this. The formula is up here, but it should also be in your exercise book. Brilliant. Quickly fly through some answers. You should have 445.1 centimetres cubed, 366.5 centimetres cubed, 301.6 centimetres cubed. Now for this one, if you're looking at thinking, I don't know how I've got that wrong, I've put the right numbers in, have you written 8 for your radius? Because if you have, you're wrong. The radius is half of that distance, it's 4. And the same here, the radius is actually 5. What you've been given is the diameter. So we should get 523.6 centimetres cubed. And for the 2 here, 3 significant figures, 314 and 1020. Now if you've struggled with round to 3 significant figures, just write down the answer anyway, because actually remember we talk about what would we get points for, and we get points for our working out and showing some element of understanding. So even if you've not rounded it properly, if you've written the formula and you've substituted the numbers in and you've written the initial answer, that gets you points. Right, next thing. We're going to have a look at this problem-solving question. It does link to our prior learning, like the previous lesson, mass density volume. I would like you to have a look at this question and see if you can work out what you need to do. Maybe sketch the cone and then have a go at answering the question. Just do what you think you need to do. Please pause the video as you do this. Right, brilliant. So we're going to have a look now at our sort of level 4, level 5, top of level 5 question. So a solid metal cone has a base radius of 6 centimetres and a vertical height of 8. Brilliant. We've got the radius, it's here, it's 6, we're told it's 6, and we've got the height as 8. Again, you could draw the cone if it helps you. Now we're told the density of the metal is 3.1 grams per centimetres cubed. Work out the mass. Now again, we should be familiar with this from chapter 16. To get the mass, it's density times volume. The issue we've got is we don't know the volume, but if we know the formula and we've been given the radius and the height, we can now find the volume. So let's put our information in, and on your calculator, if you've not done this, please do it as we go through. You should have got that answer. Don't delete it. Leave that exactly as it is. Do not round your answer at this point to anything. We've got our volume. We know to find mass it's volume times density, so let's times by 3.1, and then we get our answer of 935 grams to the nearest whole number. The reason we know it's grams is, remember before I said to you, the density is in charge of the units for the volume and the mass. Well, we know that's the volume, so mass must be the grams. Right, brilliant. We're now going to look at this compound shape. Now again, it looks quite difficult. It's not really. We're looking again at the volume of a cone, well, we've been using that today, and then the volume of a cylinder. We've not looked at that explicitly today, but we have before, and we didn't mention the fact that actually lots of the formula of a cylinder is the same as the formula of a cone. So if you could quickly first copy down the diagram for me, just sketch it, and then put these 2 formulas, and we're going to work through the answer together. So just pause the video, please, as you just jot down the formulas and the diagram. Brilliant. So we'll work through the cone first. Let's substitute in the values that we know. Okay, perfect. Then let's substitute in the values that we know for the cylinder. We've got the radius and we've got the height. Here's our height here, it's 2. Okay. Now when you get those 2 answers, you can add them together. Or alternatively, you can put that in your calculator and then do plus that. If you get a funny issue like a syntax error or a bizarre answer, try putting brackets around your first equation, then an addition symbol, and then brackets around your second equation, and you should get 497.4 centimetres cubed. Try to do the problem with the brackets around the different equations and without, and just check what answer you get, because if you get this answer with either, it means you don't have to use the brackets. Right, brilliant. If you can just pause the video and have a go at this question. Excellent, well done. So again, we'll look at what we substitute in to find the volume of the cone and then to find the volume of the cylinder. You should know by now what your calculator needs you to do based on the previous question, and you should have got an answer of 1,282.8 feet cubed rounded to the nearest decimal place. Now just be mindful that when the units change, because we're always used to millimetres, centimetres, metres, here it's feet, and it's really important that if you're not given the units, you must put them in correctly yourself, otherwise we lose points. Right, lovely. If you could have a go at these two questions. Now, what I would initially like to do is just ignore what it says here. I just want you to find the actual volume, not in terms of pi, find the volume. And then if you would like to, as an extension, also write down your answer in terms of pi. Please pause the video as you do this. Very good. So for question 4, you should have 2,563.5 centimetres cubed to one decimal place, and therefore 816 pi. You should have 2,261.9 millimetres cubed, or 720 pi millimetres cubed. Notice how with all these examples, just because it's in terms of pi doesn't mean these units are now not important. You must also include them. Right, brilliant. Next thing, we're not calculating the surface area of a cone. Actually, the next thing says, what is the surface area? But I don't want to insult your intelligence because we did this last lesson. We know it's everything you can touch. So if you think about a party hat that has a base on it this time, it's that base that you can touch, and it's the curved outside face. So let's have a look. Curved surface area plus the area of its circular base. So here's what's important, and I want you to look for something in particular. There's your formula. Now again, this pi r squared, that's just the area of a circle. We've used that loads, okay? This is the formula to find the surface area of the curved outside face, the one that slants up into the apex. Now what's important here is, what does this L mean? Because actually on the diagram it's called the slant height, okay? So the L is the slant height here. This we're no longer interested in. It's nothing to do with the surface area. It is for the volume, not the surface area. So if it's ever given, if that perpendicular height is given, it's not important. It's all to do with the radius and the slant height. Please pause the video as you jot down this formula. Brilliant, so we're going to go through an example together. So there's our first cone. What I would like you to do is just follow the example and then pause the video at the end to copy it down. So first things first, we're going to find the surface area in terms of pi, and then find the full surface area not in terms of pi. So if we look here, what I've done is I've broken it down to the two formula. We're going to use our calculators here. So first things first, we're going to find the surface area of the curved outside face, and that's pi times radius times length. Well, the radius is 12 and the slant height, which is the L in the formula, is 10. Then we're trying to find the surface area of this circle base, which is pi r squared, so pi times 12 squared. So your answer in terms of pi, which is the first thing that will appear on the screen of your scientific calculator, is 264 pi centimetres squared, because it's surface area. And then we can press our SD button and we get 829.4 centimetres squared. Please pause the video as you copy this example down in your book. Brilliant. I would now like to have a go at this example as well, and please use your calculator, put the substituted values into the formula, answer in terms of pi, and then the full surface area. Please pause the video as you do this. Right, good. So here are the values you should have substituted in. Now if you're already looking at it thinking, hang on a minute, I've put 8s in here for the radius. Remember, that's the diameter. The radius, the diameter is here, the full distance is 8 across from circumference to circumference, cutting through the centre point of the circle. We want the radius, which is half, so it's 4 centimetres. So we do pi times 4 times 10 plus pi times 4 squared, and you get 56 pi centimetres squared. and 175.9 centimetres squared. If you've got this right, give yourself a big tick. If you haven't, please pause the video here and just put the corrections in. Right, well done. If you could now have a go at finding the surface area of these cones. We've got standard and non-standard examples. There's some questions where you're given extra bits of information you don't need. Please write your answers to one decimal place and just be careful with your working out and with your diameter and your radius. Please pause the video as you have a go at these questions. Right, brilliant. So our answer should be 50.3 metres squared, 235.6 centimetres squared, 282.7 metres squared, 108.4 centimetres squared, and 549.8 centimetres squared. Now, if you put your answer in terms of pi, it doesn't tell you to do that here. If you ever have to leave your answer in terms of pi, you will explicitly be told to do it, okay, because it's more unusual. Right, really well done for getting through the lesson. It's lots of formula again. I'm sure you're doing brilliantly. Again, there's no Hegarty tasks, but there are 2 online Microsoft Form quizzes for you to do. So the links for these, I know you can't click on them on the video, but they're on the PowerPoints, they're on the college website, and they're also on the weekly guidance sheet that Mr. Glover puts on the college website, or that you might have been sent by your class teacher. Again, have a go at them, have a go at the questions, use your calculator, and your result will ping through to your class teacher. If you want some extra practice, there will be some purposeful practice worksheets as part of the weekly resources folder as well. Really well done, Year 10. You're doing brilliantly. Just keep going.